Jeg har startet.
Super. Good, we're back. This is the fourth and final video. Now we're going to talk about 3D printing. I can see that I have a mouse on my slides. Good, just wanted to remove that real quick. I've mentioned it before, I'm going to mention it again. We are doing this as a part of the Discover Robotics via STEM and Erasmus Plus project. We are FabLab Nordvest. I'm Anton Hermann. I'm almost an engineer, almost finishing my master thesis as of now. And I'm going to teach you a little bit of what I've learned over the years of working with robotics and STEM, both through my bachelor thesis, through my study, and also just hobby life. And now we're going to dive into something that I would very much consider a part of my hobby life, which is 3D printing. I had a university professor tell me that no one who is serious about it calls it 3D printing. He said it's called additive manufacturing. He might be right. I don't consider myself being a part of the very serious part of the business. I do it mostly for fun, mostly because I can when I have a 3D printer at home, and I do. I think my roommate likes it, that I build random clothes hangers and holders for trash cans and stuff. That being said, the products that I create are not necessarily the most pretty, but I do think 3D printing is awesome, and I am going to teach you just about the basics so that you can kind of venture into this world and start building small figurines and stupid hobby projects. As I've mentioned, we do call it additive manufacturing. It is, in this context, a layered process. The most common 3D printer technology that we see today is, by the most part, a simple stepper engine, a computer, and a glue gun. It's not more complicated than that necessarily. We're just very good at controlling the flow, using the right kind of plastic, and having very accurate motors. And then we learned how to program them as well. The technologies have become many. There are not only different 3D printing technologies, you can also 3D print with different materials, being plastic, being metal, wood-like things as well. It has become a staple in modern prototyping, and there was a reason that I thought it was amazing to get it at home, and that's because when I do all these small projects with Arduinos and electronics, it's really cool to just be able to create the physical part of it immediately at home as well. Most common brands right now, I'd say, are the Prusa Research. They have been a big part of pushing the open source community and pushing how to create the software around these very good printers. I would still probably recommend Prusa to people who are new in this area and do have a bit of money in their wallet. They're not even close to being the most expensive, but they are considered a kind of premium in the very cheap end of 3D printing. If you want something that's more factory ready, I can recommend Bamboo Lab. They do have some following, but that being said, if you do go onto Reddit and check it out, there might be a lot of kind of more political statements. But objectively speaking, it does seem like their printers are pretty good. A very, very used printer is the Creality Ender. It is very much in the cheap end of 3D printing, and it has a lot of kind of cult following. What I find very weird about this following is that they buy this printer to almost change each and every part of it, which to me does not make a lot of sense. But that being said, if you are very much into kind of just getting your first printer, I do think it's a very good brand, and then as slowly as you start having a little more money in your pocket, you can kind of keep building on it and learn more about the basics of 3D printing as you go along. So by any rights, they do create a lot of value in the market. I almost forgot to mention, these printers are what we call FDM printers, which is fused deposit modeling. That is the kind of the analogy that I showed earlier with the glue gun on engines. I am later going to show a brief video of how my Prusa at home works, and kind of so you can see this glue gun analogy for yourself. It works by just simply extruding thermoplastic in a program pattern controlled by a computer. And in that regard, it's really simple. Then we have SLA printing, stereolithography, which is a process where we have a resin in a kind of a small pool, and then we shoot lasers into it, making it crystallize in a very specific pattern. So instead of extruding and melting hot plastic, we are kind of drying out liquid plastic instead. Doing it this way with these lasers, we are able to have a much larger grade of detail. They are used very much in the figurine environments around the world. People who are into things like Warhammers or Warhammers 40k and maybe just Dungeons and Dragons. People really love these printers for their amazing details. That being said, they are more expensive and the materials that they use for printing are quite hazardous. So do be wary that you don't want to have one of these in your room without some serious suction in that specific cabinet. Just a small note is that these printers are very closely related to the metal printers that we are seeing come out now, where just instead of drying out a plastic, we are welding metal together. But essentially the technology is the same. So now we've talked briefly just about the different technologies. As much as I do think they're amazing, I did an entire project just analyzing CNC machines because I thought it was fun and great at university. I do understand that not everybody feels like this. It's more important to be able to execute. So now we're going to talk about how you actually design the figurines that you then can 3D print, the limitations of 3D printing, and what things you need to work around as you go about it. In this context, we're going to talk mostly about the kind of FDM style printing, where you have this layer by layer extrusion of plastic, which again does have some limitations. The picture here you see is a small figurine of an eagle that I designed for a local sports club where we play a variation of golf, where we do still make eagles. So I did this small tag just to give an example of a part that or like how a component could look when being 3D printed. One of the most important values to consider is the wall thickness. We basically never want to print objects that have 100% what we call infill. Basically, within the shell of the product, we create much more both stronger and material efficient structures, making the product both lighter, stronger, and cheaper to make. However, the shell or the thickness of the shell is a very important part of the actual strength. So when printing, this is one of the variables that we can control when we want a project to have more or less of, you can say, a certain mechanical property. Then there is the element of bridging. Think that you have two Lego bricks 2 centimeters from each other, and you want to take your hot glue gun, glue from one to the other. It's very unlikely that you can make a straight line between them just gluing into thin air. It's the same for 3D printing. With short distances, generally we say less than 1 centimeter, we actually can do this because the printer works so fast that it kind of like a rope just tightens up and there's no falling towards the ground. But as we start to increase the distance, we're going to see the plastic kind of curve down towards the bottom, and that is what we call bridging. Or bridging is covering this distance, and we don't want the falling or arcing. So generally speaking, it does come down to what material you're using, but kind of aim for the 1 centimeter goal when you're designing your components. Then there's the element of overhang. As of now, things are changing as we kind of become better and better at programming 3D printers. But as of now, we're not able to 3D print into free air. That being said, there are certain angles where we can kind of print tiptoeing on top of each layer. We can kind of go further and further and further and further out. And the most likely limit for your 3D printing technology is around the 45 degrees. Anything more than that, we're going to see a dysfunction and we're going to see the layers kind of drop. So stick to 30 or 45 degrees when you're designing or putting your components on the base. Then there's holes. I have spent many hours reprinting parts where I created holes. I'm like, it's gonna fit perfectly, and it didn't. Holes are a science, and you need to just practice, understand your printer, understand your filament. Generally speaking, adding 2 millimeters is a very, not 2 millimeters, 0.2 millimeters is a very good ground rule. But it does come down to the size of the nozzle that you're using and the type of printer that you're using as well, as some of these software actually are able to offset this when they are creating the code. Then there is horizontal holes that kind of go through it. I will say 3D printers are not that bad at this. The hole have to be quite big to not be covered in the either overhang or bridging scenario. That being said, if you kind of want it to look more clean, a drop shape is a much better option than a full hole, as we will on big holes run into the issue of the angle being too great and the printer not actually going to do an overhang. Going to do a bridge. Then there's the element of orientation. Orientation is super important, both in terms of printing your part in the way that you want. That is one element of orientation, but also in regards to mechanical properties. The adhesiveness of layers, even though we can also work with this and increase it or decrease it, is not as strong as the actual material that we are printing. So do think sometimes, what way do I actually want this part to be strong in? How do I want it to be strong when printing it? Then there's design software. We use CAD programs, computer-aided design. We basically mathematically define a figurine so that the computer can then translate the figurine into code or into a path for the printer to follow. There are a lot of different software out there. Most commonly used, I'd probably say Fusion 360 or Onshape. And in some professional environments, SolidWorks is also very used. I've used this a lot in university. Even Rhino has, by any means, a lot of following. It is really about just being able to create figures in a specific format that allows for it to be sliced up and created into a path for the 3D printer. And I'm going to go into just some simple examples of how we work with them, these types of programs, when we're designing just simple parts for 3D printing. And again, the next step, as I've kind of mentioned, is the slicing software. Slicing is where we translate the CAD file into actual lines of plastic for our printer to print. I, with my Prusa printer, use the Prusa slicer, but there are definitely others out there who are almost just as good, like the Cora slicer or more professional slicers as well. Oh, a slicer is a software that cuts the figurine into many layers. So slicing it up, think of you having a very sharp knife and just taking it layer by layer, thinly, and then being able to construct those one at a time on top of each other. So how do you move on from here? You don't necessarily have to have any skills in CAD software. No CAD software, have access to it. The easiest way is to go to one of the forums like Printables or GrabCAD and grab a very simple model for yourself if you have access to a 3D printer. There are so many models out there that are super amazing and cool that others have designed for you to print. So take advantage of this and try and print something cool and see if it's something that you really like doing and if it inspires you to create your own. That being said, I will try and teach you a little bit of how to work with just simple CAD software and creating your own components. And lastly, I just wanted to give an honorable mention for Tinkercad. We've used it earlier for circuits where it's really good. It also has a very simple CAD software that's very suited for making simple projects and teaching kids. So for both students and teachers out there, if you're just looking to get started, I can very much recommend just using this to create your first simple projects. And that's it. I'm going to go into just a couple of example videos, but from the studio here, we are finishing up. And I just want to very much thank everyone who has tuned in. Thank you for following along with this project. It's really cool that we can get funding to teach kids around Europe to know more about STEM, which is for many of us who work with this every day a great passion. And we do hope that some of you pick this up and become passionate about it yourself. At least here from Copenhagen, I just want to say thank you. Have a great night and keep learning. Hello everyone. Now I'm going to do just a very quick video on 3D printing with Tinkercad, how that works. So what you have here is the Tinkercad 3D model view. You have the view dice, which is very common for many 3D modeling programs. We can kind of say, okay, we want a top view, side view, front view, etc. So I'm going to choose the top view for now. Let's say I want to do something rather simple. We can just say, take a square here. This square work plane that we have is in millimeters. So I just kind of rotate it down a little bit here. That is the right click option. We mark this with the left click. We can hold shift to mark larger parts, or actually we don't even need to hold shift here. Roll in and out, closer, further away. Hold that to move up and down, left and right. So we have this box for now. Let's say I want to maybe add a top to it. So I'm going to build something on top here. I definitely don't want that to be that big. So maybe just like this. That looks good. It's kind of centered right on top, right there. And then we want to do something a little different. I want to make maybe a hole in the middle. Then I say, I want to make this a hole. I want to make it a little taller, a little narrower here. Then maybe I can put it right here in the middle. That kind of gives us this very simple figure. So remember like the different rules. Like I could, for example, build another square here. Maybe add a square top that here. Goes a little bit in the way. The other one, let's just do this. Control C, Control V, like here, boom. Put a big square. Whoop. put it up here, then we can just drag it out. We just have to be aware that these things might necessarily work when we print them, right? So these issues are not going to be resolved unless we use tons of what's called support materials, so we don't really want that. Just kind of delete this again. So let's just try and build this very simple little thing. Again, you can practice using just measurements and stuff to make this better. But it is, honestly, it is really that easy to do it. I'm just going to try to see if I can center this a little better. I don't know if that's a full option with the dimension it has got. So that looks a little better. Cool. Now we say grab this. Let's see, SimLab, blocks, bricks, and export. So really want to just kind of export this for Fusion. Should be good. STL is fine. And here, if you wanted it for laser cutting, you could use this instead. And then there's Fusion is a better program made for making larger CAD models. But again, when you're starting out, this should be plenty good. So I'm going to export it here as an STL. And then because I have this on my computer, it automatically opens. So you can see now I have it in what is called the Prusa Slicer. And the Prusa Slicer is a software program that allows me to make these figurines into code that the 3D printer can then understand. So we have it here. I have selected what kind of quality I want, what kind of material I'm going to print in, the infill, which is how much of the inside structure that's going to be, and then I simply just push slice. And then here you can see all the different layers. What here it's going to do 80 layers, so we can kind of roll through them like this to see how it builds. And if you want to look at more of the infill, what happens, that's the red thing, you can see that here. It kind of has an interesting pattern to it because that increases the strength of this small little product. So what I'm going to do now is I'm going to turn on my printer, just quickly grab an SD card and kind of transfer it, because what we do now is export the G code over to that SD card, and then we can print the file from the printer. Sometimes you might have the you can say the printer directly connected to the computer, allowing you for different settings, but my printer is standalone, so I will need to export it onto an SD card and then move it from there. But so in a second I'm going to show you the video of how it looks when it prints. So that is kind of also the end for me speaking to you. I hope this just helped a little bit understanding of how to get started with 3D printing. There's many steps to take on this journey, and I'm sure that if you figure out the first one, just making something as simple as this, then the next project becomes just a little easier, and then you can kind of work your way up from there. So good luck and have a good time printing.